Imagine, for a moment, drifting silently through the vast black void of space. Stars streak past you like distant lanterns in an endless night. Then, almost out of nowhere, a tiny blue marble catches your eye. A swirl of white clouds, oceans and land masses spinning gently in the cosmic darkness. That small, fragile sphere is our home, Earth. And yet, despite billions of people having lived on it, Earth holds secrets that could baffle even the most curious astronomers. Tonight, we're going to explore some of the most unusual, astonishing, and often overlooked astronomical phenomena tied to our planet. Let's start with something that seems simple, yet hides a profound mystery: Earth's color. From space, Earth shines a mesmerizing blue, earning it the nickname the Blue Planet. But why blue? It's not just the oceans reflecting sunlight. The answer lies in the atmosphere itself. Tiny molecules of nitrogen and oxygen scatter sunlight in a process called Rayleigh scattering. Blue light waves scatter more than red, giving the planet its ethereal azure glow. But here's the twist. Without our atmosphere, Earth would appear as a dull gray rock, like the moon. That delicate veil of gases is not just a shield, it's a cosmic painter, coloring the planet for anyone peering from the stars. Now, consider Earth's place in the solar system. Unlike Mercury or Venus, our planet enjoys an almost perfect tilt, 23.5 degrees, that creates the familiar cycle of seasons. But this tilt is not fixed. It wobbles ever so slightly over thousands of years in a phenomenon called axial precession. Every 26,000 years, Earth completes one wobble, subtly shifting the orientation of its poles. This wobble has profound implications. It changes the night sky, alters the timing of the seasons, and even influences long-term climate patterns. To an alien astronomer looking at Earth over millennia, these shifts might make our planet appear almost like a living, breathing organism, constantly changing its face. And speaking of living organisms, Earth's magnetic field is another cosmic marvel. Stretching thousands of kilometers into space, it shields us from deadly solar radiation. But it's not permanent. Earth's magnetic poles have reversed hundreds of times in its history. Sometimes, compasses point south instead of north. During these reversals, the magnetic field weakens, exposing the surface to solar winds. Life adapts, plants and animals adjust, and the planet endures. This invisible force field is a silent guardian, yet scientists are still puzzled by the exact mechanisms that flip the poles. But let's zoom out further. Earth's orbit around the Sun is often imagined as a perfect circle, yet it is a slightly squashed ellipse. This eccentric orbit, combined with gravitational nudges from the other planets, especially Jupiter and Saturn, subtly changes the distance between Earth and the Sun over tens of thousands of years. These variations, part of what scientists call Milankovitch cycles, have played a crucial role in triggering ice ages and warm periods throughout history. In other words, the rhythm of life, the rise and fall of civilizations, and even the advance of glaciers might all be linked to these celestial dances. Finally, consider this: the Moon, Earth's constant companion, a silent witness to our planet's history. Its gravitational pull not only tugs at our oceans to create tides, but also stabilizes our axial tilt. Without the Moon, Earth's climate would be far more chaotic, and the seasons far less predictable. In the grand cosmic lottery, we won a stabilizing partner that allows life to flourish in ways unimaginable on other planets. In just these few glimpses, Earth already feels like more than a planet. It feels like a story written in both science and wonder. And we're only scratching the surface. Hidden rhythms, cosmic coincidences, and astronomical curiosities abound, waiting for us to notice. Have you ever wondered how long a day really is? We say 24 hours, yet Earth refuses to conform so neatly. In fact, the length of a day is constantly shifting, though imperceptibly to us. Tiny gravitational tugs from the Moon and Sun slow our planet's rotation by about 1.7 milliseconds per century. That's right. Millennia ago, a day was only about 22 hours long. Imagine ancient humans living under a sky that rose and set faster than ours. And one day, in the far future, Earth's rotation could slow enough that days might stretch longer than 25 hours. Our sense of time, so rigid in daily life, is actually just a fleeting illusion, defined by the slow wobble of a spinning rock in space. Even stranger, Earth itself has a voice, though silent to human ears. Seismologists call it the Earth's hum, a continuous vibration detectable across the planet. It isn't caused by earthquakes or storms. Rather, the hum resonates from interactions between the atmosphere, oceans, and Earth's solid crust. You could almost think of the planet as an enormous bell, vibrating subtly as the sun and moon tug on it, as oceans rise and fall, and as the wind brushes across continents. If we could translate these vibrations into sound, the planet might play a symphony billions of years in the making, a music of celestial origin. Now, let's venture into a quirk of Earth's orbit, the phenomenon of planetary resonance. Earth isn't alone in its gravitational ballet. Jupiter, the king of planets, and Saturn, its stoic partner, exert tiny but persistent tugs on our orbit. Over thousands of years, these nudges cause Earth's orbit to oscillate ever so slightly, producing patterns that affect climate, ice coverage, and even the stability of oceans. It's almost as if the giant planets are whispering instructions to our small world, orchestrating cycles that dictate the rise and fall of glaciers. And while we're looking skyward, consider Earth's atmosphere as an astronomical lens. During sunrise or sunset, the sky near the horizon turns a vivid red or orange. But did you know this is more than a pretty spectacle? These colors are a subtle reminder of cosmic dust, volcanic ash, and even micrometeorites constantly colliding with our planet. Every sunrise and sunset is like a cosmic postcard, carrying whispers of the universe's activity and Earth's tiny role in it. Here's a phenomenon that truly bends the imagination: Earth's twin days. Twice a year, around March and September, the Earth experiences what astronomers call the equinox, when day and night are nearly equal. But here's the cosmic oddity. Because of Earth's elliptical orbit, the solar day, from noon to noon, is not exactly 24 hours during these periods. In fact, the apparent position of the sun in the sky can shift enough that sundials would momentarily lag or leap compared to our clocks. It's a tiny reminder that human timekeeping is a convenience imposed on a planet that moves to its own complex rhythm. Finally, consider Earth as a space traveler. It orbits the Sun at an astonishing 30 kilometers per second, over 108,000 kilometers per hour, while spinning on its axis. And yet, we feel none of this motion. It's a testament to the delicate balance of forces, gravity, and inertia, keeping us glued to a sphere hurtling through darkness, with no visible signs of speed. Every breath we take, every wave that laps the shore, every shadow cast by a tree exists because the Earth is not just a stage, but a dynamic participant in a cosmic performance. Earth, as we see it now, is not a static sphere. It's a living chronometer, a resonating bell, a dancer in a gravitational waltz. And this is just the beginning. There are mysteries yet more staggering, hidden patterns in Earth's orbit, strange electromagnetic phenomena, and celestial coincidences that almost seem too perfect to be accidental. The universe is full of rules, but Earth is full of surprises. If you've ever played with a compass, you may have thought of it as a simple tool. North points north. But Earth's magnetic field is far more enigmatic than that simple arrow suggests. Stretching tens of thousands of kilometers into space, it creates a protective bubble called the magnetosphere, deflecting deadly solar winds that could strip away our atmosphere. Yet this shield is anything but static. Magnetic poles drift, sometimes at astonishing speeds. In the early 20th century, the North Magnetic Pole was moving less than 10 kilometers per year. Today, it shifts more than 50 kilometers annually. Scientists watch this invisible wanderer with both fascination and concern, because a pole reversal, where north and south swap places, could expose Earth to intense cosmic radiation, temporarily disable satellites, and even scramble animal navigation. What's even stranger is that the source of this field lies deep in Earth's core, where molten iron and nickel swirl like a gigantic metallic whirlpool. These movements generate the geomagnetic field through a process called the geodynamo. Think of Earth as a massive, self-powered generator, humming invisibly beneath our feet. Without it, life as we know it might never have survived. Solar winds would have scoured the oceans, and our delicate atmosphere could have been lost to space. In this sense, Earth's magnetic heartbeat is as vital as the sun itself. Earth's cosmic choreography continues with an almost eerie precision. The Moon, our gravitational companion, is gradually drifting away at about 3.8 centimeters per year. Over millions of years, this slow separation will lengthen our days and weaken the tides. In the distant future, humans might witness 30-hour days or tides that barely ripple the shores. It's astonishing to think that even the Moon, seemingly eternal, is slowly altering the rhythm of life on our planet. And then there's the near-perfect coincidence that allows solar eclipses. The Moon is about 400 times smaller than the Sun, yet also about 400 times closer to Earth. This creates a rare phenomenon. During a total solar eclipse, the Moon appears exactly the same size as the Sun in the sky, blocking it completely for a few magical minutes. Step outside, and day turns to night. The corona blazes in iridescent glory. Animals pause, as if aware of the cosmic alignment. This perfect ratio is fleeting on a geological timescale, meaning we live in a unique era when such eclipses are possible. Imagine the improbability. The odds of this alignment happening at exactly this moment in Earth's history are astronomical. Even Earth's orbit has peculiar quirks. Unlike Venus or Mars, which have extreme tilts or slow rotations, Earth spins at just the right speed and sits at an ideal distance from the Sun. The so-called Goldilocks zone is no accident. Too close, and oceans would boil. Too far, and they would freeze. Combined with the stabilizing presence of the Moon, Earth maintains a climate capable of supporting complex life. It's as if the universe conspired, through countless cosmic variables, to create the perfect conditions for life, a delicate balance that could have been disrupted by a slightly larger asteroid, a different planetary alignment, or a minor shift in the Sun's energy output. Finally, Earth's very atmosphere is a remarkable astronomical filter. Not only does it protect us, but it also transforms sunlight into colors and patterns that define our perception of the world. The familiar blue sky, the reds and oranges of sunset, even the auroras dancing near the poles, all are the result of cosmic interactions. Charged particles from the Sun collide with gases in our atmosphere, creating celestial light shows visible across vast regions. These displays are reminders that Earth is not merely a planet. It's a dynamic observer of the universe, translating invisible cosmic forces into phenomena we can see, feel, and hear. In every way, magnetic, orbital, rotational, and atmospheric, Earth is a planet of astonishing coincidences, rare stability, and subtle motions. It's a world finely tuned, almost impossibly, to support life while moving through the chaos of the cosmos. And yet, we barely scratch the surface. From hidden gravitational rhythms to cosmic alignments that seem too precise to be random, Earth continues to whisper its secrets to those who are willing to listen. Earth is not just a silent participant in the solar system. It leaves its fingerprints on the cosmos in ways most of us never notice. Consider meteorites, for example. Some originate from asteroids, or even the Moon and Mars. But countless tiny particles rain down on Earth every day, carrying clues from distant parts of the solar system. Ironically, Earth also sheds material into space. Microscopic particles from volcanoes, deserts, and even the oceans can escape into orbit, slowly drifting through the solar system. If another civilization had the right instruments, they might detect traces of Earth scattered across millions of kilometers, a silent signature of our existence. In a sense, Earth is leaving breadcrumbs for the universe, quietly asserting, life exists here. And then there's the atmosphere, which behaves like a cosmic lens and a cosmic shield simultaneously. When sunlight passes through it at dawn or dusk, the air scatters light in extraordinary ways, painting skies in reds, pinks, and purples. But beyond beauty, the atmosphere is a living record of Earth's history. Tiny particles trapped in ice cores reveal volcanic eruptions, cosmic collisions, and even the intensity of ancient solar storms. By studying the gases suspended above us, astronomers and geologists can peer back into the deep history of our planet and, surprisingly, into the wider solar system. Our atmosphere is not just a shell of air, it is a historical archive, written in invisible ink across every cloud and breeze. Auroras offer another example of Earth's strange connection to the cosmos. The ethereal greens, purples, and reds dancing across polar skies are caused by charged solar particles colliding with atmospheric gases. While auroras occur on other planets too, Earth's magnetic field shapes theirs into patterns that are uniquely ours. It's almost as if the planet has a signature style, a cosmic brushstroke painted across the sky. And these light shows aren't just beautiful. They're reminders of the invisible interactions between Earth and a sun that is constantly sending out energy, radiation, and charged particles into the solar system. Even our geological history carries cosmic signatures. Giant impacts from asteroids shaped not only Earth's surface, but also its life. The most famous, 66 million years ago, ended the reign of the dinosaurs, creating conditions for mammals, and eventually humans, to dominate. Evidence of this cataclysm remains buried in layers of iridium, a rare element more common in asteroids than on Earth. In a way, our planet's destiny has been written, in part, by the stars themselves, with celestial collisions leaving scars that still influence life today. Perhaps the most astonishing coincidence involves Earth's rotation, orbit, and moon. The combination of day length, seasonal tilt, and tidal forces is almost impossibly precise. A slightly faster or slower spin, a different axial tilt, or a missing moon would drastically alter climate, ocean currents, and even the length of a year. These factors have allowed complex life to evolve, survive ice ages, and thrive in stable ecosystems. When astronomers model alternate scenarios, it becomes clear. Earth exists in a sweet spot of cosmic parameters that may be extremely rare in the universe. Finally, there are whispers of even subtler mysteries. Some researchers have observed faint correlations between solar activity cycles and geological phenomena on Earth: volcanic eruptions, earthquakes, and even climate shifts. Whether these are causal or coincidental is still debated, but the suggestion is tantalizing. Earth may be more entwined with the cosmos than we have dared to imagine, a responsive participant in a web of solar and planetary rhythms that spans millions of kilometers. Earth is not merely a rock spinning through space. It's a storyteller, a timekeeper, and a cosmic performer. From atmospheric colors and auroras to meteoric signatures and orbital coincidences, it communicates a complex, beautiful, and astonishing narrative of existence. The more we explore, the more we realize that our planet is not only home, it's a rare jewel in the darkness of space, a living record of both cosmic chaos and improbable order. Step back and look at the solar system as a whole. Venus rotates backward, Mercury spins sluggishly, Mars tilts wildly, and the gas giants dominate with their immense gravities and storms larger than continents. Amidst all this chaos, Earth occupies an extraordinary niche: the perfect distance from the Sun, a stable tilt, and a rotation speed just right to balance days and nights. This delicate combination allows oceans to remain liquid, climates to remain temperate, and seasons to nurture life. It's a cosmic alignment so precise that even slight changes, Earth slightly closer or farther from the Sun, a longer day, or a missing moon, could render the planet uninhabitable. Consider Earth's orbit, nearly circular yet subtly elliptical. This eccentricity interacts with gravitational tugs from Jupiter and Saturn in patterns that stretch over tens of thousands of years. These Milankovitch cycles influence ice ages and warm periods, shaping the course of life on Earth. In other words, massive planets billions of kilometers away dictate when glaciers advance, deserts expand, or forests flourish. Earth does not merely drift through space, it dances to a rhythm set by distant giants, a rhythm that has allowed life to adapt, evolve, and flourish. Even the speed of Earth's rotation is finely tuned. Too fast, and winds and weather patterns would become violent storms. Too slow, and temperatures could swing to extremes between day and night. At roughly 1,670 kilometers per hour at the equator, Earth spins at just the right velocity to support a habitable climate. This spin also interacts with the Moon's gravity to produce the tides, which, over millions of years, may have played a critical role in the emergence of life. The rise and fall of oceans created coastal habitats, tidal pools, and environments where life could experiment, adapt, and ultimately thrive. The Moon itself is a cosmic marvel. Its size, distance, and gravitational pull stabilize Earth's axial tilt, ensuring seasons remain predictable. Without the Moon, Earth might tilt wildly, creating extreme and unpredictable climates. It's remarkable. A single celestial companion, orbiting at just the right distance, contributes so much to the stability of life on our planet. Few worlds in the universe are likely to be this lucky. Then there's Earth's magnetic field, a shield against solar radiation and cosmic rays. Generated deep within its molten core, it not only protects life, but also interacts with the Sun in ways that create auroras and subtly influence the planet's climate. This field, combined with the atmosphere, ensures that sunlight is filtered, radiation is reduced, and the planet remains a safe haven in the otherwise hostile environment of space. Even the solar eclipses, rare and fleeting, are the result of improbable coincidences. The Moon is perfectly sized to cover the Sun in our sky, despite being vastly smaller. This alignment will not last forever. Our Moon is slowly moving away. Future generations may never witness such total eclipses, making our current era uniquely privileged in the history of the cosmos. In essence, Earth is not simply in the right place at the right time. It is a world finely tuned by countless interacting variables: rotation, orbit, tilt, companion bodies, magnetic shields, and atmospheric chemistry, all combining to make life possible. When we study other planets, we realize that few, if any, possess this balance. Earth is rare, fragile, and astonishingly well-placed, a living testament to the improbable beauty of the universe. Earth appears steady, serene, and predictable from our perspective. But zoom out, and the planet is anything but static. One of the most fascinating hidden movements is axial precession, a slow wobble in Earth's rotation that takes roughly 26,000 years to complete a full cycle. Imagine a spinning top, gradually tracing a circle as it wobbles. Over millennia, this wobble shifts the orientation of the poles and changes the position of stars in our night sky. Constellations rise and fall over long epochs, and the timing of the seasons subtly shifts. Ancient civilizations unknowingly tracked this cosmic rhythm, creating calendars and structures aligned with stars that, due to precession, no longer match the night sky. The Earth itself keeps time, but on a scale far beyond human lifetimes. Earth also hums in ways that are inaudible to our ears. Scientists detect continuous vibrations, called the Earth's hum, which ripple through the planet even without earthquakes. These faint oscillations may be caused by ocean waves, atmospheric pressure changes, or interactions with Earth's magnetic field. The hum is a subtle reminder that Earth is alive in a physical sense, constantly moving, resonating, and responding to forces both internal and external. If we could hear it, it might resemble the faint background music of the cosmos itself, a lullaby of planetary existence. The atmosphere, too, hides mysteries tied to the cosmos. High above, in the thermosphere and ionosphere, charged particles from the sun collide with gases to create dazzling auroras. But these solar interactions also influence radio waves, satellite communications, and even long-term weather patterns. Solar storms, massive eruptions of charged particles, can disrupt electronics on Earth and even induce currents in power grids. In essence, our atmosphere acts as both shield and messenger, translating cosmic events into phenomena we can perceive and study. Earth's wobble and vibrations have effects we rarely consider. They influence climate cycles, ocean currents, and even the distribution of ice ages. Tiny changes in Earth's tilt or rotation can amplify or reduce solar heating in different regions, setting off centuries-long patterns of droughts, floods, or glaciation. In this way, forces originating millions of kilometers away, the sun, moon, and planets, shape the destiny of life in subtle but profound ways. Another remarkable phenomenon is the Chandler wobble, a small, irregular movement of Earth's rotation axis discovered in the late 19th century. This wobble shifts the poles by a few meters over a 14-month period. While tiny in scale, it reminds us that Earth is not a rigid, immovable sphere. It's a dynamic, living system, constantly responding to gravitational pulls, ocean currents, atmospheric pressure changes, and even melting ice. Every movement, no matter how minute, is a thread in the complex tapestry of planetary life. Finally, Earth interacts with the Sun in rhythms that remain mysterious. Sunspots, solar cycles, and the fluctuating solar wind can influence climate patterns and even biological cycles. Some studies suggest subtle correlations between solar activity and phenomena on Earth, such as rainfall, earthquakes, or magnetic anomalies. Whether these are coincidences or hidden connections is still debated, but the possibility alone hints at a planet more intimately tied to the cosmos than we might imagine. Earth is not just spinning through space. It is swaying, humming, vibrating, and dancing to rhythms dictated by the universe itself. Each subtle motion and hidden resonance carries secrets about the forces that shaped our planet and continue to influence it today. The more we study, the more we realize that Earth is a living, breathing participant in a cosmic symphony, and we are fortunate witnesses to its astonishing, intricate dance. Earth seems ordinary when you look up and see the sky, but in reality it is full of near-miraculous coincidences. Take solar and lunar eclipses, for example. A total solar eclipse occurs when the moon perfectly covers the sun. This alignment is astonishing because the sun is about 400 times wider than the moon, yet also roughly 400 times farther away. This geometric coincidence is temporary. Over millions of years, the moon is gradually moving away from Earth, making future total eclipses impossible. We are living in a rare window of cosmic timing, privileged observers of a celestial spectacle that will vanish for future generations. Then there are the tides, a phenomenon so subtle that we often take it for granted. The moon's gravity tugs at Earth's oceans, creating bulges of water that rise and fall in a rhythmic dance. But tides do more than create waves. They regulate climate, shape coastlines, and even influence the earliest forms of life. Tidal pools, constantly filled and drained, provided the perfect laboratory for life to experiment and evolve. Without this lunar pull, the evolution of complex organisms might have followed a completely different trajectory, or never occurred at all. Earth's orbit itself is a cosmic balancing act. The planet sits at a distance from the sun that allows water to remain liquid, a key ingredient for life. Too close, and oceans would evaporate. Too far, and they would freeze. But that's not all. Earth's orbit is just eccentric enough, combined with axial tilt and gravitational interactions with other planets, to create predictable seasons and long-term climate cycles. These subtle forces maintain a balance so delicate that even minor variations could have prevented life from thriving. Another extraordinary coincidence lies in Earth's rotational speed. Spinning at roughly 1,670 kilometers per hour at the equator, our planet maintains a day-night cycle that is neither too fast nor too slow. Faster rotation could generate extreme winds and chaotic weather. Slower rotation could cause temperatures to swing drastically between day and night. Combined with the stabilizing influence of the moon, this rotational speed has allowed Earth's climate to remain temperate enough to support complex ecosystems. Even the sun contributes to this cosmic jackpot. Its size, energy output, and lifespan are unusually stable. A slightly larger star might burn too hot, evaporating water and stripping the atmosphere. A smaller star might not emit enough energy, freezing oceans and halting life. The sun's stability over billions of years has provided a predictable energy source for life to flourish. Then, there are subtler coincidences. The way Earth's magnetic field shields us from solar and cosmic radiation, the precise composition of the atmosphere that protects life while allowing photosynthesis, and the wobble of Earth's axis that creates long-term climate rhythms. Each of these factors on its own might seem random, but together they form a planet exquisitely tuned for life. When you consider all of these coincidences together, distance from the sun, rotation speed, axial tilt, magnetic field, moon's presence, orbit, eclipses, tides, and atmospheric composition, the odds of such a perfect combination occurring seem astronomically low. Earth is not merely a planet, it is a rare cosmic experiment, a unique blend of conditions that have allowed life to emerge, survive, and evolve into the extraordinary diversity we see today. It is humbling to realize that we live on a planet whose every motion, tilt, and orbit is part of an intricate cosmic choreography. Earth is both ordinary and extraordinary, a planet that whispers secrets about the universe and, at the same time, about the astonishing luck and balance that made life possible. Earth is not just a planet orbiting a star, it is a participant in an intricate cosmic network of forces, subtle rhythms, and near-miraculous coincidences. One of the most fascinating phenomena is Earth's interaction with its moon. We often think of the moon as a static companion, but it actively shapes the planet. Its gravitational pull creates tides, yes, but it also affects Earth's rotation and axial tilt. The moon's stabilizing effect prevents extreme tilts that could make climates chaotic, ensuring a predictable seasonal rhythm. Without the moon, Earth's axis might wobble wildly, creating climate swings so extreme that life as we know it might not survive. Even more mysterious are the subtle solar influences on Earth. The sun emits not only light and heat, but streams of charged particles called the solar wind. While the magnetic field shields us from most of this radiation, variations in solar activity can affect everything from auroras to satellite operations. Solar cycles, typically 11 years in length, appear to influence atmospheric conditions and even subtle climate shifts. Some scientists have even found correlations between solar activity peaks and changes in Earth's weather patterns, hinting at a deep connection between our planet and its star, a conversation in invisible forces, stretching millions of kilometers through space. Earth also participates in planetary resonances, gravitational interactions with Jupiter, Saturn, and even Venus. These distant giants nudge our orbit subtly over thousands of years, producing long-term climate cycles and influencing the distribution of ice and warmth across the planet. It's astounding to realize that storms, droughts, and glacial advances on Earth may be partially orchestrated by planets millions of kilometers away. Earth, in this sense, is a cosmic dancer, following a choreography dictated not only by its own motion, but by the rhythms of the solar system. There are even hidden vibrational patterns within Earth itself. Seismic studies reveal that the planet resonates at very low frequencies, sometimes described as the Earth's hum. Unlike earthquakes, this hum is continuous, produced by interactions between the atmosphere, oceans, and crust. If translated into sound, it would be a low, eerie melody, the faint music of a planet responding to forces both internal and cosmic. It's as if Earth is listening, feeling, and subtly moving to the rhythm of the universe. Then there are astonishing coincidences in our solar vantage point. For example, Earth is one of the few planets where an observer can see both lunar and solar eclipses, and where oceans cover enough of the surface to interact with tides, atmosphere, and climate in a unique dance. Our axial tilt, orbital eccentricity, rotation speed, moon, and magnetic field all converge to produce a combination of phenomena nearly impossible to find elsewhere. The planet is simultaneously ordinary, a rocky world orbiting a star, and extraordinary, perfectly tuned to support life. Even more mind-bending is the way Earth's seasons and climates are tied to orbital wobbles and axial precession. These cycles, unfolding over tens of thousands of years, dictate long-term climate patterns, influencing everything from ice ages to periods of warmth. It is humbling to realize that life on Earth has adapted to, and even depended on, these invisible cosmic rhythms. The planet is alive with patterns we cannot always see, whispering secrets about the forces that govern its history and future. Earth is, in every sense, a rare cosmic phenomenon. From hidden vibrations beneath its surface to delicate alignments with the moon and sun, every aspect of the planet is tied to the universe in ways we are only beginning to understand. Each sunrise, eclipse, aurora, and tide is a reminder that we inhabit a planet both ordinary and miraculous, a world inextricably woven into the fabric of the cosmos. Earth is a planet defined by a delicate balance of coincidences, almost like a finely tuned instrument in a cosmic orchestra. Consider the orbital eccentricity, the slight elongation of Earth's path around the Sun. Unlike Mercury or Mars, whose orbits are highly eccentric, Earth's orbit is nearly circular, providing stable distances from the Sun throughout the year. This stability ensures that temperatures remain suitable for oceans to stay liquid, creating conditions for life to flourish. A slightly more elongated orbit could produce extreme seasonal swings, turning temperate regions into scorching deserts or frozen wastelands. In other words, Earth's near-perfect orbit is no trivial detail. It is a fundamental requirement for life. Combine this with Earth's axial tilt, currently about 23.5 degrees. This tilt produces seasons, but it is also stabilized by the moon. Without this stabilizing force, Earth's tilt could vary wildly, plunging the planet into chaotic climates over millennia. Imagine summers where temperatures soar to extremes and winters so harsh that even the hardiest species could not survive. The moon's quiet gravitational influence is a constant, invisible hand, maintaining the conditions necessary for ecosystems to develop, flourish, and endure. Then there is axial precession, a slow wobble of the planet over roughly 26,000 years. This wobble shifts the orientation of Earth's axis relative to distant stars, altering the timing of seasons in ways imperceptible to us day to day, but critical over geological time. Precession affects long-term climate patterns and even the distribution of ice ages. Without this subtle motion, Earth's climate history might look entirely different, potentially hostile to complex life. Earth's rotation speed is another finely tuned factor. At roughly 1,670 kilometers per hour at the equator, the planet spins fast enough to create day-night cycles that moderate temperature extremes, but not so fast that winds and storms become catastrophic. The rotation also interacts with tidal forces from the moon, producing tides that have been essential in shaping coastal ecosystems, encouraging biodiversity, and even influencing the evolution of early life. Every revolution is a carefully measured step in an intricate planetary dance. The magnetic field adds yet another layer of improbable perfection. Generated deep within Earth's molten core, it shields the planet from harmful solar radiation and cosmic rays. Without this invisible barrier, life could not thrive on the surface. The field itself is dynamic, flipping and wobbling over millennia, yet somehow it persists, maintaining its protective role despite violent internal and external forces. Consider the probability of all these factors converging. Near circular orbit, stable axial tilt, perfect rotation speed, tidal interactions, protective magnetic field, and the presence of the moon. Each factor alone is remarkable, but together they form a constellation of coincidences so unlikely that Earth seems almost designed to support life. Scientists often call this the rare Earth hypothesis, the notion that while rocky planets may be common in the galaxy, planets with this precise combination of features capable of supporting complex life may be exceedingly rare. In essence, Earth is a living symphony where every note, the orbit, tilt, rotation, tides, and magnetic shield, resonates in harmony to sustain life. Even the most subtle deviations could have created a hostile, barren world. Our existence is intertwined with the precision of cosmic mechanics, a delicate interplay that has allowed life to evolve, adapt, and thrive in a universe otherwise indifferent to our survival. Earth is a world of extremes, not just in its cosmic alignments, but also in the dramatic phenomena that unfold on and above its surface. Take lightning storms, for instance. Lightning strikes over 8 million times a day across the globe, creating a natural display of raw energy. But it also plays a crucial role in life. The intense heat breaks apart nitrogen molecules in the atmosphere, creating nitrates that fall to the soil as vital nutrients for plants. In this way, a spectacular storm is not only a visual marvel, but also a contributor to the intricate web of life on the planet. Auroras, meanwhile, are another breathtaking reminder of Earth's cosmic interactions. Charged particles from the sun collide with atmospheric gases, producing shimmering curtains of green, red, and purple across polar skies. These are not merely beautiful, they are evidence of the planet's magnetic field at work, funneling energy in a way unique to Earth. Other planets have auroras, but the combination of Earth's magnetic field, atmosphere, and distance from the sun creates patterns and colors unlike any other known world. Earth's geological features also reflect its uniqueness. Consider tectonic activity. The movement of massive plates shapes continents, forms mountains, and triggers earthquakes and volcanic eruptions. While destructive, these processes have sculpted environments that allow ecosystems to thrive. Volcanoes, for example, release gases that replenish the atmosphere and deposit minerals critical for life. Without tectonic activity, Earth might have remained a flat, lifeless rock, devoid of the rich biodiversity we see today. Even stranger are the cosmic coincidences embedded in Earth's geology. Some scientists suggest that asteroid impacts, which might seem catastrophic, have actually been pivotal in shaping life. The impact that wiped out the dinosaurs 66 million years ago, for instance, cleared ecological niches that allowed mammals, and eventually humans, to dominate. Craters and impact layers preserved in the geological record are reminders that the fate of life on Earth is closely tied to events occurring millions of kilometers away in space. Earth's atmosphere itself is finely balanced, composed of roughly 78% nitrogen and 21% oxygen with traces of other gases. It filters harmful radiation, moderates temperature extremes, and allows photosynthesis, the engine of life. Even minor deviations in this composition could make the planet inhospitable. Too much oxygen, and fires would rage uncontrollably. Too little, and complex life could not exist. Combined with atmospheric pressure, cloud formation, and weather patterns, our sky is a protective and dynamic envelope that shields life while connecting it to the broader cosmos. Finally, consider rare phenomena such as bioluminescent bays, polar vortexes, and supercell storms. Each is a product of Earth's unique combination of water, rotation, atmospheric composition, and solar input. Even the occurrence of double sunsets in certain regions or extreme tidal bores in rivers like the Amazon can be traced to precise alignments of celestial forces and planetary features. These wonders are not accidents. They are the natural expressions of a planet finely tuned to its environment and universe. Earth's atmosphere, geology, and cosmic coincidences are not merely fascinating. They are reminders of how extraordinary our planet truly is. Every storm, aurora, mountain, and tidal wave is a note in the intricate symphony that makes Earth alive, vibrant, and unique in ways that stretch the imagination. In observing these phenomena, we are witnessing the outcomes of a rare cosmic balance, one that allows life to exist and flourish amid the vastness of space. Earth does not exist in isolation. Every motion, every tilt, every subtle wobble is part of an intricate web connecting the planet to the moon, Sun, and the rest of the solar system. The Moon, for instance, is more than a shining companion in the night sky. Its gravitational influence creates tides that shape coastlines, regulate ocean currents, and influence weather patterns. Over millions of years, tides may have even guided the evolution of life from shallow waters to land. Without the Moon, Earth could have a chaotic rotation, unpredictable seasons, and far less stable climates. The Moon is a stabilizer, a silent cosmic partner whose presence has been essential for life as we know it. The Sun, too, plays a critical role. Its stable energy output ensures that Earth remains within the habitable Goldilocks zone, not too hot, not too cold. Solar cycles subtly affect climate and atmospheric phenomena, while solar flares and winds interact with Earth's magnetic field to produce auroras and influence high-altitude weather. The Earth-Sun relationship is a finely balanced interplay of forces that have persisted over billions of years, providing a consistent energy source while allowing dynamic, life-supporting processes to unfold. Finally, consider the improbable combination of factors that make Earth unique. Its stable orbit, perfect tilt, ideal rotation speed, protective magnetic field, presence of the Moon, dynamic atmosphere, and location in the solar system. Each element alone is remarkable, but together, they create a planetary system extraordinarily rare in its suitability for complex life. Earth is not just a planet. It is a cosmic miracle, a hub of life shaped by forces both seen and unseen. A world where hidden rhythms and celestial coincidences converge to sustain the delicate balance of existence. Earth is a stage for some of the most extraordinary astronomical coincidences in the solar system. One of the most striking is the solar eclipse, a fleeting moment when the Moon perfectly covers the Sun. This alignment is astonishingly precise. The Moon is about 400 times smaller than the Sun, yet about 400 times closer to Earth. For a brief few minutes, day turns to night. The Sun's corona bursts into view, and the world experiences a cosmic spectacle few other planets could host. What makes this even more remarkable is that the Moon is gradually drifting away at roughly 3.8 centimeters per year. In a few 100 million years, total eclipses will no longer occur. We are living in a rare window of cosmic timing, witnessing a phenomenon that may never repeat for future generations. Then, there are solstices and equinoxes, subtle astronomical events that regulate the rhythm of life on Earth. The axial tilt of 23.5 degrees ensures the cycle of seasons, giving temperate regions the balance of warmth and cold needed for ecosystems to thrive. But this tilt is not fixed. It wobbles slowly due to precession. Over millennia, the positions of solstices and equinoxes shift, subtly influencing climate patterns and even ice ages. These cycles, imperceptible to human lifetimes, demonstrate how Earth's astronomical position affects the long-term evolution of life. Earth's tides, driven by the Moon's gravity, create another rare alignment of cosmic and terrestrial forces. The rhythmic rise and fall of oceans influence coastal ecosystems, nutrient cycling, and even the early evolution of life in tidal pools. Tides also interact with Earth's rotation, gradually slowing the planet over billions of years and lengthening the day. The combined effect of lunar gravity, rotation, and ocean dynamics is a rare phenomenon that few planets could replicate with such precision. Even the planet's orbit itself is a delicate balance. Earth circles the Sun at an average distance of 150 million kilometers, perfectly positioned in the Goldilocks zone, where water remains liquid and climates are habitable. But slight eccentricities, combined with gravitational tugs from Jupiter and Saturn, create long-term variations known as Milankovitch cycles. These cycles influence glacial and interglacial periods, indirectly shaping the evolution of life over hundreds of thousands of years. Earth's orbit is not just a path around the Sun, it is a precise, finely tuned journey that dictates the rhythms of life. The interplay of rotation, tilt, orbit, and lunar influence also governs extreme natural phenomena. Supercell storms, massive tidal bores, and atmospheric anomalies all arise from this combination of forces. Even seemingly random events, volcanic eruptions, auroras, lightning storms, are often influenced by underlying cosmic rhythms, creating a planet that is dynamic, resilient, and uniquely capable of supporting life. Taken together, these rare astronomical events and precise cosmic alignments reveal Earth as a planet of astonishing balance. Every eclipse, solstice, tide, and orbital wobble reflects a harmony of forces almost impossibly coincident. The planet is not merely orbiting a star, it is performing a delicate cosmic ballet where each motion, tilt, and orbit has been orchestrated over billions of years to allow life to emerge, evolve, and flourish. Earth's magnetic field is one of the most remarkable features that make life possible, yet it is often invisible to our eyes. Generated by molten iron and nickel swirling in the planet's outer core, this magnetic shield stretches tens of thousands of kilometers into space. It deflects harmful solar and cosmic radiation, ensuring that life can survive on the surface. Without it, Earth would resemble a lifeless rock, stripped of atmosphere and exposed to constant radiation. But the magnetic field is far from stable. It drifts, wobbles, and even reverses polarity over thousands of years. Imagine compasses pointing south instead of north, yet life persists, guided by this invisible, shifting protector. Earth's rotation and orbit create hidden rhythms that govern both natural and astronomical phenomena. The Chandler wobble, a small, irregular movement of the planet's axis, shifts the poles by a few meters over a 14-month period. This wobble, combined with axial precession and tidal interactions with the Moon, produces subtle long-term climate cycles. Ice ages, glacial retreats, and even ocean current variations are influenced by these hidden rhythms. The planet is alive with motion, resonating in patterns that extend far beyond our daily perception. Even more extraordinary is the precise synchronization between Earth's rotation, tilt, and orbit. The planet spins at a speed that moderates day-night temperature extremes, creating climates capable of sustaining complex ecosystems. Its axial tilt of 23.5 degrees produces predictable seasons, while the Moon stabilizes that tilt to prevent catastrophic swings. The orbit around the Sun, nearly circular yet slightly elliptical, interacts with gravitational nudges from Jupiter and Saturn to create long-term climate oscillations. Each of these factors alone is remarkable. Together, they form a cosmic alignment so precise that the existence of complex life becomes almost miraculous. Earth also exhibits magnetic and electrical phenomena that are rare and fascinating. Auroras, for instance, are created when charged solar particles collide with gases in the atmosphere, producing shimmering lights across polar skies. But auroras are only possible because Earth's magnetic field channels and funnels these particles. On other planets, similar collisions may occur, but without a protective magnetic shield, the particles would disperse, and life could not endure the radiation. Even lightning storms, while seemingly destructive, contribute to the nitrogen cycle, helping sustain ecosystems. The improbability of all these conditions coinciding is staggering. Orbital stability, rotation speed, axial tilt, tidal interactions, a magnetic field, protective atmosphere, and a nearby stabilizing Moon. All factors must align to create a planet suitable for life. Each small deviation could have rendered Earth inhospitable. In a universe filled with billions of planets, Earth stands out as a rare example of balance and resilience. In essence, Earth is not merely a planet in motion. It is a finely tuned system of interlocking rhythms, magnetic shields, and cosmic coincidences. From its hidden wobbles to auroras and tides, the planet is alive with subtle movements, orchestrated by forces stretching across the solar system. It is a world of improbable perfection, a delicate balance of motion and protection that allows life to emerge, persist, and thrive in a universe that is otherwise indifferent.